Okay, a review on functions and logs. You're going to use logs a lot at the end of calculus, not at the beginning of calculus, but it's still good to review logs. So, part one is a function is 1-to-1. It lets you know if the function has an inverse. To check to see if it's 1-to-1, on the test, if it asks, if the AP, they're not going to ask this, but if they ask what is it 1-to-1, you have to do the horizontal line test. Here's a parabola. Is this function 1-to-1? If you do the horizontal line test, it goes through more than once. It goes through twice. So no, parabolas are not 1-to-1. If you did a x to the third, which looks like a snake, if you drew a horizontal line, yes, it's 1-to-1. Basically, if it's 1-to-1, it cannot have repeating y value. So just do the horizontal line test to check to see if it's 1-to-1. Determine whether the function has an inverse. Just graph it and do the horizontal line test. Determine whether the function has an inverse or not. So basically, if I graph this, you can graph it on your calculator, but it looks something like this, x squared plus 5x. And all you have to do is do the horizontal line test. Determine whether the function has an inverse. Just graph it and do the horizontal line test. No, it does not have an inverse because it goes through it more than once. Find the inverse and verify it. Two functions are inverses of each other if and only if, when you find the inverse, when you put one inside the other, it equals x. You do not have to do that. I'm just going to show you how to find the inverse. It's been a while since you found the inverse. I'm going to change the f of x to a y. These two circles are exactly the same thing. I think you know. This is x and this is y, this is x and this is f of x, that this means exactly the same thing. What's really important is if this is x and this is y, you write it as this is x and this is f of x. Those are the points. You could also say, you can say this is 1, 2, this is 1, 2. They also say f of 1 equals 2, which means the ordered pair is 1, 2. You have to know that that stands for the point 1, 2. F of 1 equals 2. A lot of times they do not write it like this in calculus, 1, 2. They'll write it as f of 1 equals 2. Do not forget this. This is huge in calculus. So how do you find the inverse of this function? You interchange the x's and the y's. If you remember this from algebra or from college algebra, subtract 2, y is equal to x minus 2. These two right here are said to be inverses of each other. And to know if they're inverses of each other, their slopes, when multiplied together, have to equal 1. Their slopes are they're not opposite reciprocals. I want to go over that with you. Let's bring this way down here. Parallel lines have the same slopes. Y equals x plus 3, y equals x minus 2. They both have a slope of 1. Perpendicular lines have opposite reciprocals. Y equals 2x plus 3, y equals a negative 1/2 x plus 4. Opposite reciprocals. Inverses have just reciprocal slopes. Y equals 2x plus 4, y equals 1/2 x plus 7, or something like that. Parallel lines have the same slope, 1, 1. Perpendicular have opposite reciprocals. Inverses have reciprocal slopes, not opposite reciprocals. If you multiply those two together, it equals 1. So, if I did this right, if I multiplied these two together, it has to equal 1. 1 times 1 equals 1. Let's do this one down here. Y equals 5 minus 4x. This is the original. How do you find the inverse? Interchange the x's and the y's. Everybody see that I interchanged the x's and the y's? Solve for y, I get x minus 5 equals a negative 4y. Divide everything by a negative 4. I get a negative 1/4 x plus 5/4 equals y. The two circled ones are said to be inverses of each other. How do I check it? The slope of one and the slope of the other multiplied together has to equal 1. Let's do this one. This one's tricky. I'm going to put y is equal to x squared. So this is the same thing as this. I can only do when x is less than or equal to 0. So what does this look like? Right now it looks like, you know what y equals x squared looks like. It looks like a parabola. But this stipulation is really important. Right now, you can't find the inverse because when you do the horizontal line test, it goes through it twice. So I'm only going to do it when x is less than 0. So I'm going to do this part. I'm going to take away that part. Now I'm only going to have it when the x values are negative. These are the negative. Now I can find the inverse by interchanging the x's and the y's. Everybody see that? Interchange the x's and the y's. In order to get y alone, I need to square root both sides. So y is going to equal plus or minus the square root of x. But I need it to be the inverse. And it's symmetrical across the line y equals x. So in order for, which one am I going to pick? The positive square root of x, which looks like a swoop, or a negative square root of x? You want it to be symmetrical across this line. I don't want this one. I only want the negative one. This one and this one are said to be inverses of each other. I can do the same thing with this one. I can graph, put my first dot at 5, go down 4 and over 1, and I can put negative 1, put my first dot at 5/4 and go down 1 and over 4. And they connect right here. And if I put that line, it's supposed to be symmetrical on both of them, so. Okay, now we're gonna get into logs very quickly. We're just gonna review logs because that deals with the inverse. The inverse of an exponential equation is a log, you guys. I'm hoping you know that. So these are the properties. If these two are the same, it equals 1. You can take this little 2 and put it out in front. It's 2 times the log of base 2 of x. 7 raised to the log of base 7 of x is equal to x. I'm going to do another one. 3 raised to 2 log of 3, 2. Remember, if this is the same with this, it would equal that, but that 2 can also put up here, which is equal to 4. So remember that law. If these are the same on both sides, then you can say x equals 4. If there's a minus, you can rewrite it as 1 log of base 2, but you can, if there's a minus, you're really dividing 8 divided by 4, which is equal to the log of base 2 of 2, which is equal to 1. If you want to separate them, you can do the log of base 3 of x plus the log of base 3 of y, because multiplication really deals with addition when you're doing logs. Logs can switch over to natural logs, and every natural log has a base e. So if there's another e here, I forgot, let's start back here one more time. Let's go back up here. The log of base 3 of 9 equals 2, and I know that's right because I do the loop around to know that I did it right. 3 to the second equals 9, and I'm going to do the loop around to check the natural log. E raised to the first has to equal E, so the natural log of E is equal to 1. Don't ever forget that, and you learn that in Algebra 2 and in college algebra. Again, natural log has a little e, so what's x going to equal? E raised to the 0 has to equal x. Anything raised to the 0 is equal to 1. So that's just a quick little review on logs. And we just have a couple more slides to go. Solve for x. Well, if it's a natural log form, I know that there's a little e there, so I'm just going to go e raised to the 3t plus 5 equals x. I just did the loop around, and I got x alone. If it's an e form, I can put it back. The natural log, I know the little e goes here. I know 21 goes here, and I know 3x goes here. E raised to the 3x equals 21. See how I put everything in the right spot? But it says to solve for x up here. So the last thing I'm going to do is divide both sides by 3 to get x alone. To solve for x, do the loop around. 4 to the third equals x. So x is equal to 64. 4 times 4 times 4 is 64. I want to solve for x. This is a good one. I'm going to put the natural log of 4 minus the natural, no, I'm going to go the opposite way. I'm going to do x equals the natural log of 12 minus the natural log of 4. I got these together on the same side. Now I'm going to use the rule that says if there's a minus sign, I can divide these, which is the natural log of 3. You're going to use a lot of this at the end of the year, but I still wanted to review natural logs because it's in this section. And I think this is it. This is, oh, we got a couple more pages. 2 more pages. Draw the graph of y is equal to log of base 2 of x plus 1 and find the domain and the range. So, basically, if you think about what a log is, I want to bring this back again. This is an exponential function, correct? This is y is equal to ab to the x. Well, a log is the inverse of this. So what's the inverse of this? If this went through 0, 1, the inverse of it has to go through 1, 0. And it looks like this. So basically, you have to draw the log of y is equal to log of base 2 of x plus 1. I'm going to use the shifting. It's going to move side to side because it's inside the grouping symbol. It's supposed to start at 0, 0. I moved it to the left 1. So here's my, on this one there's a horizontal asymptote. On this one there's a vertical asymptote at 0. So I'm going to move my vertical asymptote over 1, and I'm just going to go through 0, 0 instead of 1, 0. Draw the graph of y equals the log of base 2 of x plus 1 and find the domain and the range. The domain is the x values. It's everything except a negative 1 because there's a vertical asymptote to infinity. And the range is a negative infinity to a positive infinity. So let's do another one. Let's do the log of base 7 of x minus 2 instead. Well, you know that it looks like the usual one usually goes through 1, 0, and it looks like this. Well, I'm going to move it from the 1. I'm going to move it to the right 2 because remember negative means goes to the right. So I move my dot to here. My vertical asymptote used to be here, remember. I'm going to move it to the right 2. So now it's here. And then I'm going to make my log. Again, what's my domain? From a negative 2 to infinity, and my range is a negative infinity to a positive infinity. I'm shifting it to the right or to the left depending on what's inside of there. If you don't believe me, you can graph this on your graphing calculator. Where do you find log? Everybody see the math button underneath alpha? Arrow down and you'll see log a base, and you can use that, but I don't use the log a base. I know how to graph it without the log a base. So, okay, part 6, I don't know why they're doing this again, but they are. They want you to figure out the answer to this problem. I'm going to let this be y1, I'm going to let this be y2. We had this in the last section. So under y1, this is just a review again from the last section on how to figure out where they intersect with each other. Under y1, I'm going to put 2.031 raised to the x, and under y2, I'm going to put 8. And how do you get intersection? You do second calculate, hit intersection. And it didn't show up really well. So what I'm going to do is I'm going to change my window. I'm going to go and zoom in and just play around with it. And it's thinking still. If you don't want to zoom in, you can zoom out, or Z decimal. See what Z decimal does. Okay, Z decimal does not work. Z decimal gives you the 2.031x, but it does not give you the 8 because the 8 is too high up. So I'm just going to go and change my window. I'm going to leave my x min and my x max, but I'm going to change my y from a -3 to a +10 and see what happens. Just play around with your window and see what happens. I've got my 2.031 raised to the x, and now I have my my y value can go all the way up to 8. I'm going to hit my calculate intersection button, move my cursor up to where I think the answer is, and I'm going to get 2.935 for my answer. You need to play around with your window. You need to maybe play around with your zoom a little bit, you guys. You guys have to get better at playing around with your window and your zoom. You can also, you guys, go to YouTube. You can Google how to play around with your window and your zoom button on a TI-84 calculator, and take some time and watch a YouTube video and get better at using your calculator. The calculator is only as smart as the person running it. The calculator can only do what the person tells it to do, and if the person doesn't know how to run the TI-84 calculator, you're going to have some problems. So you might want to maybe Google how to do a quicker refresher on how to use the window and the zoom session on TI-84. So, okay, that's all the notes for 1.5.